in the last video, you learned how to convert between wavelength and frequency. So in this lesson, you guys are going to learn how to convert between frequency and now the last concept that I had introduced before, which is energy. Okay, so how exactly do you calculate energy? Well, there's a formula that will be given to you, and that is E equals H times nu. Okay, so E is your energy, and the units for energy are going to be joules. H is Planck's constant, and that is going to stay the same always. That will always be given to you. And so that value is 6.626 times 10 to the negative 34th joules times seconds. And then, of course, your frequency, whose units are seconds to the negative 1. And so that makes sense because if you multiply joules times seconds by seconds to the negative 1, or 1 over seconds, then the seconds cancel out and you're left with the units for energy, which are joules. So let's look at an example. Here it asks what the energy is of a photon from the violet portion of a rainbow if the frequency is 7.23 times 10 to the 14th seconds to the negative 1. And so I'm going to use my formula. Okay. I don't know my energy. I know Planck's constant. It's 6.626 times 10 to the negative 34th joules times seconds. And I know my frequency, which is 7.23 times 10 to the 14th seconds to the negative 1. And so when I multiply those out, what I get for the energy is 4.79, because I rounded based on 3 significant figures, times 10 to the negative 19th joules. So that's it. You might find some slightly more challenging problems which give you wavelength and ask you to find energy. Clearly, you can't use the wavelength, lambda, in this formula, but what you can do is use your C equals lambda times nu formula to figure out what your frequency is, and then plug your frequency in for your energy formula. And that's it.